You know, when you watch a Formula One car just screaming down a street, it's so easy to think that speed is all about raw power. But the real magic, the secret sauce that separates the good drivers from the legends, that happens in the corners. Today, we're going to peel back the sheet metal and get into the hidden physics of what makes a race car driver just so impossibly fast.
Okay, so let's just get right into it. What's the one thing, the real secret, that lets a driver shave off those precious hundredths of a second from a lap time? What's the absolute limit that they're constantly pushing up against?
You might think, oh, it's got to be a bigger engine, right? More horsepower, or maybe some super advanced aerodynamics. And yeah, those things are great on the straights, but any pro will tell you races are won and lost in the corners. The real secret is actually much, much smaller.
That's it. That's the whole game. Everything a driver commands the car to do, braking, turning, accelerating, it all has to go through four little contact patches, each one roughly the size of your hand. All the physics, all the incredible skill, it all comes down to managing the grip from these four tiny spots on the road.
So that's where we have to start. The tire. Because if you can understand this one part of the car, you unlock everything else. It's the foundation for a concept that every single race driver lives and breathes every second of every lap. And that big concept is called the traction budget. Think of it like a monthly budget for your money. Each tire has 100% of available grip to spend. You can spend that grip on braking, turning, or accelerating, but the total can never, ever be more than 100%. And you can really see that trade-off right here. It's so clear. If you use 100% of your budget on braking hard in a straight line, guess what? You've got 0% left for turning. If you're using, say, 80% of your grip to carve through a corner, you've only got a tiny 20% left to play with for braking or accelerating. The real art of racing is living right on the absolute edge of this circle all the time. So how in the world does a driver manage this budget? Well, it all plays out in three distinct phases of taking a corner. Let's break down that whole journey from entry to exit and see exactly how these incredible forces get manipulated. First up, braking. Now, for you and me on the street, we brake to stop. Simple. But in racing, you brake to turn. I know, it sounds totally backward, but it's a fundamental truth and it's all based on a cool concept called weight transfer. Just think about it. When you hit the brakes hard in your own car, what happens? You feel yourself lurch forward in your seat, right? Well, the entire car is doing the exact same thing. All that mass, thousands of pounds, pitches forward, loading up the front suspension. And here's the crucial part. That forward weight transfer is like an invisible hand literally pushing down on the front of the car. The physics are actually pretty simple. More downward force on a tire means it has more grip. It temporarily gets a bigger traction budget, right at that critical moment you need to start turning in. And this is what leads us to an expert technique called trail braking. You see, a great driver doesn't just brake then turn. No, they blends the two together. They slowly ease off the brakes as they turn the wheel, using that last little bit of forward weight to help pivot the car into the corner with unbelievable precision. It's an art form. Okay, so you've used the brakes perfectly to rotate the car into the corner. Now you're in the middle of the turn, balancing everything right on the limit. This is the moment where things can go wrong in one of two very, very different ways. You've probably heard these terms before, understeer and oversteer. Understeer is that awful feeling when you turn the steering wheel, but the car just kind of plows straight ahead. The front tires have given up. Oversteer is the opposite, and it's usually way more dramatic. That's when the rear tires lose grip and the back of the car tries to pass the front. You know, a spin out. So why does this even happen? Well, a huge reason is something called yaw inertia. A car doesn't want to rotate, especially one with a heavy engine at one end and crash structures at the other. It's just like a figure skater spinning with their arms out. It takes a lot of effort to get them turning. You have to apply a massive amount of force just to start the turn. And that right there, that's the physics behind the most common piece of racing advice you'll ever hear. When a coach is yelling, be smooth, they're really telling you not to fight the car's own inertia. A sudden jerky turn of the wheel is asking the front tires to do way too much, way too fast. You instantly blow past their traction budget and boom, understeer. Okay, let's move to the exit. We've made it through the turn, the car is pointed where we want it to go, and now it's time to get back on the power. But this is, you guessed it, another incredibly delicate balancing act. Remember how braking threw all the weight forward? Well, hitting the throttle does the complete opposite. You feel yourself getting pushed back into your seat as all the car's mass shifts onto the rear tires. This unloads the front tires and puts all the pressure on the ones in the back. And in a super powerful rear-wheel drive race car, this is where you can get into big trouble with power oversteer. You're asking those rear tires to handle the last little bit of cornering force and all that insane engine power at the same time. It's so easy to just overwhelm their traction budget, causing them to break loose and send the car spinning.
So when you put this all together, you start to realize that driving on the limit isn't about brute force at all. It's this incredibly complex, delicate dance with the laws of physics, and it's all performed in milliseconds.
I mean, just think about the driver's job in a single corner. They have to manage that tiny, finite traction budget. They have to actively use the brakes to shift the car's weight and get it to rotate. They've got to be perfectly smooth to overcome the car's own inertia. Then they have to delicately balance the power on the exit to keep from spinning, and do all of that while hitting the perfect racing line, down to the inch. As our source expert Andre Marziali puts it, the real challenge is achieving a timing accuracy on the order of 100 milliseconds. 100 milliseconds, a tenth of a second too late on the brakes or a fraction of a second too early on the throttle, can mean the difference between a perfect corner and a trip into the gravel.
So when you see a driver just nail a corner perfectly, what you're really watching is a master physicist at work. They're feeling and manipulating weight transfer, yaw, and traction, all at the absolute knife's edge of what is even physically possible.
So the next time you're watching a race, don't just look at the raw speed on the straights. Watch the car's body language in the corners. See how it dips under braking, how it rotates at the apex, how it squats down under acceleration. Will you be able to see that invisible dance with grip? I bet you will.